So as we continue on with this lesson, we're going to go into more algorithms for addition. We're only going to cover a few of these in detail, but I really encourage you to research more of them on your own. It's just that this lesson is already pretty long and I need to focus on the things that you're going to use mainly when you are teaching in your class. So as far as the strategies for addition that we've already done, I want to pull up online real quick a chart that you can possibly use. So I'm big on anchor charts. I just think it's good to have a visual around your classroom. And so for that basic addition in Kinder and First, where we're adding and subtracting within 10 and 20, I think something like this up on the wall would be great to have using pictures, making 10, the part whole mat, our doubles plus one, doubles minus one, counting on a number line, etc. This is just something that you can continually refer to if you have something like this up in your classroom. As you go into the higher grades, we would focus more so on regrouping. So we talked about that. Once you get into second grade, you're going to start adding larger numbers, and that's the first time we do the regrouping. With addition, also where we start doing borrowing with subtraction. But I really like this visual because it has the regrouping shown with base 10 blocks. And that is so important for our students to understand because it's going to help them really comprehend the standard algorithm. The other thing I like about this chart is how the place value is lined up when we have, and it also has lines in between it because at an early age, it's kind of hard for them to keep their place value lined up. So I like how this chart has the hundreds, tens, and ones with lines between it just to break up that place value. I also want to point out on the regrouping, when your students are adding two numbers, so we can see on the first one we have two hundreds, four tens, and we have ones, and then we have our second number below it. When we're doing that addition and they realize that when the ones are added together they have more than 10, they can trade that in for a long, and that really reinforces the concept of regrouping and carrying to that tens place when we do the standard algorithm. So that's a really good chart to have up in your room. Going back to the notes, I would encourage you, anything that we don't cover as far as a full example on these different strategies, I would encourage you to do some research on. You're probably not going to teach the lattice algorithm, but it's always good to have that knowledge and just kind of have that tool in your pocket. So what we're going to do on example 1 is we're going to use a concrete model to add these two numbers, and then we're also going to use the standard algorithm. So we'll just talk about what it looks like visually and then move into what it looks like using the standard algorithm and carrying that one. So when you do the concrete model, that's when we're actually going to draw it out. And I'm going to be pretty basic with my drawing. So if you're doing this in your classroom, I would highly encourage you to have base 10 blocks on the desk for your students where they can add those and trade in their pieces. So once they get 10 ones, they can trade it in for a long, and 10 longs, they can trade it in for 100. Because that's really going to reinforce the standard algorithm and the carrying of the one in addition. So I have 100, excuse me, hitting all kinds of things. It really is hard to use this pen. So we have 190. I'm just going to do straight lines for my longs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2. On the longs, when you draw those, you can obviously draw a longer rectangle. And then we have 300, 1, 2, 300, 1, 2, 3, 4, 5, 6, 7, 8. 8 tens and then 7 ones. 1, 2, 3, 4, 5, 6, 7. And so we're going to add these two numbers together. Now, when we do this addition, we're going to add our ones place. And so I'm just going to draw a line underneath here. And when I add my ones, I have 2 ones units and 7 one units. So this is going to total me up to 9 ones. And your students could count those pieces on their desk. What I see though when I go to add my tens is I'm obviously going to have more than 10 longs. And so what you would encourage your students to do, and maybe even use a different color, so I'm going to go to red here. So I have 9 of these here, and what I can do is I can pull down and get the 10th one here. And when I have 10 of these, what I can do is I can come over here and do a visual here, that these 10 tens here is going to trade in for a 100. And what that goes into when we do the standard algorithm is the carrying of that 1. Now, how many tens are left once we, group those 10 together and trade it in for a 100? And you can have your students count those. So we have 1, 2, 3, 4, 5, 6, 7, 7 tens. And then when I go down to count up my 100s, I have 5 hundreds. So I have the number 579. Now for the standard algorithm, I have 192 added to 387. We can line that up. You can do lines in between like the chart, that we did before. But 2 and 7, I am so sorry, this screen. So 2 and 7 is 9. 9 and 8 is 17. And so after, we have done the concrete model for a while, we say, okay, we have 7, but the 10 in the 17, we trade in for a 100, and that's where that carrying comes from, adding up now to give me the same number of 579. So that's addition with a concrete model using the base 10 blocks, and then also with the standard algorithm. The other algorithm that I'm going to go into with you is the partial sums algorithm, which is a little bit out of our comfort zone, but I do think it has value also. So in the partial sums algorithm, what we do is we add by place value, and we kind of write that out in an expanded form. If you go back to the chart, this sum here, expanded form, is very similar to what we're going to do. I'm going to write it a slightly different way just because I want you to be familiar with all different kinds of visuals. But when we do the partial sums, what that would look like is we're going to add the hundreds together, the tens together, and the ones together. So adding the hundreds, I have 300 and 700, giving me 1,000 when I add up those hundreds. I have 300s and 700s. Now here when I add my tens, I have 60 and 50. That gives me 110. And then on my ones, I have 8 and 7 adding together to give me 15. And basically when we're doing partial sums, it's going to be very similar to an expanded form. We're adding different place values, and then we add those sums together. So now we're going to add 1,000, 110, and 15. We have 5 here. In my tens place, I have 2. My hundreds place, I have 1. And in my thousands place, I have 1, giving me the number 1,125. So that's just a couple of different models using a couple of different algorithms. Now, if we go back online, one thing I do want to look at is if I did go back into Lead Forward, and Lead Forward, once we get there, we always go up here to the top to this resources button. And I just kind of want to, again, go into maybe like second grade math and look at this. So on second grade math, if I go into adding and subtracting, we can see here under whole number operations that we're going to add and subtract within 1,000 using a variety of different strategies. And that's where we actually have to, when we get to within 1,000, that's when we have to start doing the carrying and the borrowing. If you get over here and really spend some time looking into these teaks, you're going to kind of see where that comes up. And I just want you to take a moment and maybe read through these on your own and look at the different vocabulary. The next thing we're going to go into in this lesson is some mental strategies. And I remember when my sons, I have 2 sons, were in second grade, and I remember them coming home and learning some of these mental strategies, and they're so important and so beneficial. So I just wanted you to see that that is in second grade. If we go into third grade, I'm going to open the third grade, and if we go into addition and subtraction of whole numbers, you can kind of read and see, how it progresses from third grade into fourth grade, and we do more two-step type problems in third grade, and that's going to be how it kind of advances. But I just want you to always, when you're looking at what you're supposed to teach, you really have to take time to dig in and study the standards that the state of Texas has written for us to make sure that we're teaching everything appropriately. So I pointed out in second grade, there is an actual TEK talking about doing mental computation. And then we're going to go into estimation, but I don't want you to confuse the two. Mental math is when you're actually getting the real answer. It's not an estimation, but you do it with a mental strategy. Computational estimation is where we approximate the answer, so it's not an exact answer, it's an approximate answer. And the next part of this lesson goes into different strategies for both of these. So we're going to do some mental strategies, and I think this is really critical because a lot of times our students struggle with this. They're not good at doing math in their heads. And so especially now with technology, everybody just, gets their phone out and uses their calculator, where, the mind is actually a calculator, and there are different mental strategies of how you can do computations in your brain. So one of those first strategies is called adding from the left. And when you take your test over this unit, I'm going to be specific with strategies, and you get to use a note card. So this might be something you want to put on your note card, not because it's hard, but just because you want to keep the strategy straight. This is probably one of the easiest things we do in this semester, but you have to remember to keep a name to a strategy and keep those straight. So our first one is called adding from the left. And what we would do is we would be teaching our students how to do this in their head, but I'm going to write the steps out of what you would teach your students to do in their heads. So if we were teaching them to add from the left, the way that this would look is we would say, okay, to add from the left, we would add 40 and 30 first to get 70. We wouldn't pay any attention to adding our ones. If we were doing this strategy mentally of adding from the left, we would add 40 and 30 first. Then we would add 8 and 3 in our heads to get 11 and combine those two sums to get 81. And when you do that, you're not doing the whole process of the standard algorithm in your head. You're breaking your place values apart. So I'm going to add the 10s and the 10s and the 1s and the 1s, and then I'm going to sum those two numbers together. The way that it would look on part B, you would be doing this in your head. I'm just writing the steps out. So if we were teaching our students this strategy, we would tell them, okay guys, in your head, and I apologize. Okay, I apologize. I wrote 800 instead of 600. So in your head, you would do 200 and 600, and that gives me 800. Then we would add our 10s, 30 and 20 to get 50. And then we would add our 1s, 7 and 8 to get 15. And then in our heads, we would add this up to get 865. So adding from the left is where you basically are doing an expanded form of addition, adding hundreds, then tens, then ones, and then summing those together. So 200, 600 is 800, 30 and 20 is 50, 7 and 8 is 15. Combining those three numbers, I get 865. But the goal is that the students would do all of this in their head and never write anything down. It's a mental strategy. Now, when you're doing this on the test for me, I will ask you to write out the steps that we would expect the students to do in their head. But in second grade, it's really important that we take time to teach these strategies. The next strategy of mental math that we do, mental addition, is called breaking up and bridging. And it's a slightly different approach. This is probably an approach that I use more than adding from the left. I actually prefer this step because it combines basically two steps from the last strategy. So on breaking up and bridging, you take the first number plus the tens of the second number. So we would tell our students, okay, 48 plus 33, let's first just think of 48 plus the 30, because any number ending with 0 is easier for them to do in their heads. So when we do this, we get a total mentally of 78. Now all I need to do is take that 78 and add the 3 back onto it to give me a total of 81. And so it's a different strategy, but to me it basically combines two steps that were in the previous method. On this next one, you're going to take your first number, 734, and add 20 to it to give us 754. And we would be doing this mentally. Now I need to take that 754 and add the 8 from the second number to it, the ones place. And our goal is that our students can now do this mentally to give us 762. And if our students are really good at their math facts, if they've really taken the time to learn their math facts, whether that's by using flashcards or an app, these mental strategies are going to be much, much easier for them. Okay, trading off is another method that I use all the time in my day-to-day life because it's all about making 10 or making 100 based on what the problem is. But what I like to do when modeling this is I really prefer when I'm teaching this strategy to line the numbers up vertically to model it, and then it'll be something that they transition to do in their head. So when you look at this, what you want to do is you're going to pick one of the numbers and make it a 10. And that's up to the student, and that's ultimately up to you which number you choose to do that with. So when I see this number, I see, oh, if I just added 2 to 48, that would get me to a 10. But if I add 2 to one number, then I have to, and I apologize, I wrote 32 instead of 33. If I add 2 to a number, then I have to take 2 away from the other number. That's called trading off. It's kind of like thinking of a balance, like keeping it balanced on a balanced scale. You kind of have to do the opposite to keep it balanced. And so if I add 2 to one number, then to keep the problem the same, I must subtract 2 from the other number. And this gives me 31. But when you do that trading off, you're going to make one of the numbers a 10, and then you'll add the other number to it, and that mental computation is much easier. So I still get the same total of 81. On this second problem, if I have 64 and 49, you're going to pick one of the numbers and make it a 10. Well, I see 49 plus 1 gets me to 50. But if I added 1, I must subtract 1 from the other number, giving me 63. I then add those two together to get a summation of 113. And trading off is just another mental strategy. Our last mental strategy that we're going to look at is looking for numbers that are compatible, meaning looking for two numbers that come together to make a perfect 10. And so what I hope you recognize is that 1 and 9 make a 10, which makes these two numbers compatible, and 4 and 6 make a 10, which makes these two numbers compatible. So compatible numbers are basically just numbers that fit together nicely, and it makes it easier for us to do those additions in our head. So when I look at 61 and 39, 60 and 30 is 90. The 1 and the 9 makes another 10, so it's very easy for me to see and mentally do that that is 100. 24 and 26, 20 and 20 is 40. 4 and 6 is another 10, so that makes this 150, and summation total gives me 150. On part B, I recognize that 3 and 7 make a 10, so these two numbers are compatible. And 5 and 5 make 10, so these two numbers are compatible. When I add those together, 215 plus another 15 is a very easy number to do mentally to get 230. We know 15 and 15, the 5 and the 5 make a 10, and the 10 and 10 make 20, totaling 30. Here, 143 and 27. So 140 and 20 is 160, plus the other 10 that comes from the 3 and the 7 tells me that this is 170. And when I sum these other two numbers together, they're also compatible because 70 and 30 make 100. So when I total these up, 200 and 100 is 300, plus the other 100 coming from the 70 and 30 makes this summation an easy one to do mentally to get 400. All right, the last portion of this video, I'm going to go into some estimation strategies. And estimating is not where we get an exact answer, it's when we get an approximate answer. And there's a lot of different really fun activities that you can do with teaching estimation, and I want to pause and take a second to look at a few of those. Now to first kind of teach the concept of estimating, this is where you can do some really fun things of, estimating how many, are in this, how many would you guess, or over here, this is what 100 looks like, this is what 50 looks like, how many are in here. And so teaching estimation as being an approximate answer is there's some really fun activities that you can do. Now, after you teach estimation, you can go into teaching rounding. And when you're teaching your rounding activities, that can also be something that's really fun to do. There's all kinds of, when you're teaching rounding, fun songs and games that you can teach your students. There's a lot of really good, really fun activities that you can do with your students. And so I just kind of encourage you can go on Pinterest. If you go on to Teacher Pay Teacher, which will also have a lot of good activities, I just encourage you to, really take some time to find a good activity. And depending on the grade level that you teach, it will determine, what place value you're rounding to, the actual strategy you use for estimation. And so when you're researching and trying to find activities, you need to be specific and make sure that it matches up with your TEKS. So there's just a lot of things that you can look at. Now, going back, the first thing we're going to do is we're going to do some estimation with rounding. And what I noticed that students do a lot, even students in my class, when I tell them to estimate the answer, what they do is they add or subtract or multiply, and they find the exact answer, and then they round the answer. And that is not what you're supposed to do. You are supposed to round and then add, or round and then subtract, or round and then multiply. You don't find the exact answer and then round the actual answer. So the rule for rounding is something that I think you've probably all learned before. When you're rounding, you look at the digit to the right of the place value that's underlined. If it's 5 or greater, round the underlined digit up. If it's 4 or less, keep the underlined digit the same. Every digit following the underline digit becomes a 0. So this is where I said there's a lot of songs or sayings. And if you're teaching a grade level where rounding was taught at the grade level previously, I would definitely go to the teacher at the grade level lower than you and see if she had a saying or a song that he or she had a saying or song that they used to teach this rounding. Like there's 5 and up, shove it up. There's several different things that you can do to teach this. So if I want to round to the nearest 1,000, what this underline rule means is it means underline the place value that I'm going to round to and look to the digit to the right. If it's 5 or greater, then I'm going to round the underlined digit up, and all the digits following it are going to become zeros, meaning that this number is going to round to 25,000. If I'm rounding to the nearest 100, I underline the 100 and I look to the digit to the right of it. If it's 5 or greater, I would round it up, but if it's 4 or less, I keep it the same. So this is going to be 6,400, and then the digits following it become zeros. Final one that I'm going to round to the nearest 10. If I underline the tens place and I move over and look at the digit beside it, this is kind of a special situation here where it's a 9 and beside it is also a 9. So a 9, if it's rounding up, rounds up to a 10, which also transforms to the place value beside it. And so rounding this to the nearest 10 is going to take us to 5,000. Now what we're going to do now is we're going to actually do some computations, some addition using estimation. And we're going to go through these strategies, and that will be the end of this video. And then the third and final video of this lesson will be going through subtraction. So when we're doing computational estimation, there's different strategies, just like there were different strategies for doing mental addition. So front end with adjustment is going to involve some rounding. And so what we're going to do when we're doing front end with adjustments is, first of all, we're going to consider the hundreds, okay? So if I just consider adding the hundreds, that's 5 and 3 and 6. So if I add 5 and 3 and 6, when I add that together, I get 14. But those were all hundreds, so I have to add 2 zeros back to that. Then I'm going to make adjustments as far as I'm going to choose to round the other numbers. And because they're all tens, I'm going to round them to the nearest 10. So 38 is going to be approximately 40. 79 is going to be approximately 80, and 25 is going to be approximately 30. And this is where we're making the adjustments, into the tens place. So I added my hundreds up, I adjusted my tens. When I add those up, and you're just going to use, mental math to add these up, 40 and 80 is 120, plus 30 gets me to 150. And when I add now those two numbers together, 1400 and 150, I'm going to get 1550 is approximately this answer. And that's with some adjustments, meaning with some rounding. And I'm going to do the same thing on the next problem. I'm going to add the hundreds, so 4 and 3 and 1. So 4, 5, 6, 7, 8. 4 plus 3 plus 1 is 8, but those are hundreds, so I'm going to add those two zeros. And then I'm going to make adjustments, meaning I'm going to round to the nearest tens. So I have 57 rounds to 60, 28 rounds to 30, 44 rounds to 40, and then I will add those up, totaling 130. Add these two numbers together. The answer to this is approximately 930. And that strategy for doing the addition with front-end adjustments gives me an approximated answer, but notice I never once found the exact answer. And so this is just one of the strategies. The next strategy that we're going to go into So the next estimation strategy that we're going to go into is looking for numbers that fit together nicely, kind of just like our compatible numbers. And this is where, I'm going to kind of give you freedom, because sometimes we don't always see the same things as fitting together nicely. And so what I kind of look at is it just pops off the page at me. I can see this is about 100. Like this is approximately here 100. And I just see that. It just pops out to me right here. When I look at this is approximately 50. It just pops out like these two numbers together are approximately 50. These two numbers together are approximately 100. And then I say, well, this is approximately 60. And so those are just numbers that have come together nicely for me. And when I work together to add up these numbers, I know that an approximate answer for this is 210. And so when you're doing this and you're doing your strategies, we're combining rounding and approximating to approximate the sum. And notice we never found the actual exact answer. So like I said, what a lot of students will do is they will add up the numbers exactly and then round that answer. And that's not how approximating with addition works. When I go to the next problem and I look at this, these two numbers pop out to me because I know that this is about 40 and this is about 60, which are compatible. And so when I look at these two numbers, 300 and 500 is 800, and then about 40 and about 60 gives me another 100. And so I can tell that this is about 900. This here is approximately 400. And when I add 400 and 900 together, I get that my answer is approximately 1,300 or 1,300. Clustering is one of my favorite methods. It's something that I generally will always put on the test, but it can be more missed, and it's just a matter of students overlooking and not paying attention to the naming of the different strategies. So clustering does not always work. And sometimes, it's kind of actually rare that it does work. The only time that clustering works is when all of the numbers being added together basically round to the same thing. And that's why it doesn't always work, and it's actually rare that it does work. But when I look at these four numbers, I can see that they all round to approximately 4,000 if I'm rounding to the thousands place. All four of these have an estimated average of approximately 4,000. And that's why this problem's not going to work on every problem. It's only going to work if all of your numbers that you're working with can be rounded to the same thing. Well, if they all are approximately 4,000 and there's 4 of them, all I have to do is do 4 times 4,000 to get an approximated answer here of 16,000. And so that's called the clustering method, and that's something that I want you to pay close attention to. The next thing you're going to do on this strategy is I want you to come up with, write a set of 5 numbers in which the clustering method is a good strategy for estimating the sum. And then we're going to come up with a set of 5 numbers where it doesn't work, because I want to point out to you that this only works if you come up with 5 numbers that can all be rounded to the same thing. And then we'll need to come up with 5 numbers that don't all round to the same thing. So I'm just going to make some up, and you can make up your own as well. But let's say I give you 1,860 plus 2,211 plus 2,003 plus 1,970 plus, we'll say 1,899. Now the reason the clustering method would work is because all 5 of these numbers, 1, 2, 3, 4, 5, all 5 of these numbers, if we rounded to the nearest 1,000, would round to 2,000. And that's why this would work. And then we would just do 5 times 2,000 to approximate this answer. Now if I had a problem of 7,260 plus 2,342 plus 511 plus 8,910 plus 1,860, there's no way we could use this method here because these numbers do not all round to the same thing. And so the clustering method will work if all of your numbers can be rounded to the same number. And then you just do that number times however many numbers you have. All right, 2 more strategies in this video. Rounding and using the range. So when we do rounding to approximate our answer, we don't actually find the answer first. We do the rounding and then we do the operation. And like I said, this is where students mess up. They will add and get the exact answer and then round the answer, and that's not what we want them to do. Now, sometimes teachers will, tell you, I want you to round to the nearest 10, or I want you to round to the nearest 100, or I want you to round to the nearest 1,000. And sometimes that's indicated in the problem, but sometimes it's not. And so if it's not, you just have to make an educated guess. Like for example, on this problem, I'm going to round to the nearest 1,000. This is going to be approximately 6,000 plus approximately 3,000 to make my approximated sum 9,000. Because the problem didn't tell me what place value to round to. Now in the next problem, I'm not going to round to the nearest 1,000. I'm going to round to the nearest 100. To the nearest 100, this is 2,500 minus 600. And the reason I did that is because 613, if I round to the nearest 1,000, I'm getting definitely farther from the actual answer. This is now doing subtraction, so 2,500 minus 600 makes this answer approximately 1,900. So that's using rounding to come up with an estimated answer. Round first, then do your addition or subtraction. And then the last strategy, which I also think is a fun strategy, is called using the range. And that's when you do a low and a high estimate. So you round low, then you round high, and you know that the actual answer is somewhere in the interval of your 2 estimations. And so this is how this is going to work. You're going to do a low estimate, and you're going to do a high estimate. So when you round low and high, you're pretty much completely ignoring the rules for rounding. If I round low, I'm rounding to 7,000 and 3,000. If I round high, I'm rounding to 8,000 and to 4,000. Now I do the summation. Here I get 10,000 and here I get 12,000. But when you do that low and high estimation, you now have a range of, I know my answer is somewhere between these 2 numbers because I rounded low and high. So the actual answer here would be between 10,000 and 12,000. And that's using the range to just give a range of the summation of these two numbers has to be between here and here because I did a low and a high estimate. All right, again on this next problem, we're going to do a low estimate and a high estimate. So low estimate is 300 plus 500 to get 800. High estimate is going to round me to 400 and 600, adding to 1,000. And so my answer here is the addition of these two numbers is between 800 and 1,000. I give a range of the answer has to be between this and this. And I apologize since this video is a bit long. We just kind of had a lot to cover, but you can now stop this video and move on to the third and final video of this lesson.